Reactions of acids, bases, carbonates, and metals. Acids react with bases, carbonates, and metals. When people eat acidic foods, they may get indigestion due to excess stomach acid, HCl. Relief can occur when a person ingests antacid medicine that contains the base magnesium hydroxide. The base neutralizes the acid, here's our acid, forming the salt magnesium chloride and water. When a solution is neutralized, that means its pH is 7. It is neither acidic or basic. Oftentimes, when acids react with bases, the result is a salt and water. Some bases, like ammonia, NH3, do not contain a hydroxide, but for now we'll just show hydroxide bases. A common reaction is hydrochloric acid plus sodium hydroxide yields sodium chloride, which is your salt, and water. And these little letters here mean something. This is an aqueous solution. It's a solution in water. That's aqueous. And this just means water is a liquid. Let's look at a carbonate reaction now. This reaction was presented in the previous unit, where its endothermic nature was discussed. The reaction produces a salt, carbon dioxide, and water. So here's our carbonate, sodium carbonate. Here's ethanoic acid. It forms sodium acetate plus carbon dioxide plus water. Sodium acetate, which is this, has many applications as it can neutralize acids and maintain a constant pH. It's used in food preservatives, treating patients with high blood acid levels, rubber production, textile industry, and photograph development. Acids react with metals to form hydrogen gas and a salt. Bases rarely react with metals to form hydrogen gas and a salt. Here we have hydrochloric acid reacting with zinc, and that little s there means it's a solid, forming the salt zinc chloride, and aqueous here means it's in solution, plus hydrogen gas, and that's what the G stands for. When the zinc is dropped in the hydrochloric acid, bubbles appear and leave the liquid. The bubbles are hydrogen gas molecules, and if your teacher holds a lighted match near the surface, you can hear quiet pops. Soluble substances such as salt and sugar dissolve in water. Insoluble substances such as sand, fats, and wood do not dissolve in water. Here are some examples. For soluble salts, we have sodium chloride, or table salt, calcium chloride, that lowers blood pressure, flavors food, and is applied to roads for de-icing. Potassium nitrate, it's a fertilizer, also used in food preservatives, propellants, and fireworks. And insoluble salts would be silver chloride, used in pottery glazes and photographic paper, and calcium sulfate, which is also known as gypsum and is used to make wallboard and tiles for homes, and plaster of Paris. We can make soluble salts by reacting an insoluble reactant, such as a metal or a carbonate, with an acid. And here's the process. First, add a dilute acid, such as hydrochloric acid, to a beaker. Slowly add a powdered insoluble reactant to the beaker. Keep adding the reactant until it doesn't dissolve anymore. The excess reactant then will fall to the bottom of the beaker. All the acid has now reacted. So the beaker contains a solution of water and the soluble salt and the non-dissolved reactant. And we'll continue on the next slide. Finally, filter out the non-dissolved reactant with filter paper. Evaporate the fluid by heating or just letting it sit. The beaker will now include pure, dry, soluble salt crystals. And if you click on this website here, there's a nice video that shows the preparation of copper sulfate crystals.